This is the first section on the chapter on the binomial expansion, and what you're going to be learning in this chapter is how we can apply the binomial expansion to powers where the power is negative and the power is a fraction. Now, you've already done binomial expansions where, for example, I don't know, you might have had something like 2x minus 7 to the power 5. And you know that there's like a finite number of terms. So I think in this there'll be 6 terms, I think, something like that. So there's a finite number of terms. So it comes to an end because basically as the power of one thing goes up, the other thing, the power of the other thing goes down until you get to the end. Yeah, so you'll get something like your first term would be 2x to the power 5, then the next term would be negative 7 times by 2x, or 2x to the power 4, and then we'd need our coefficients here. So let's put those in our NCR, which need to go in. So we would have 5C0 for the first one, 5C0 plus, and this would be 5C1 plus ... And when we get to the very last term, it's going to be 5C5, and we'll end up doing negative 7 to the power 5. So you come to an end. Yeah, this is the last term. You stop because of this 5C5 thing. You're done. You can't, you're not going to do 5C6. You come to an end. When the power is negative or fractional, the expansion is infinite, because fractions and negatives, if you keep taking one away from the power, you're never going to end up to that point where the power becomes 0. So binomial expansions, this is important, binomial expansions where the power, or n, is negative or fractional are infinite expansions. They go on forever. Now, the thing with infinite expansions, then they normally only make sense if they converge. That means that each term is smaller than the last. You did that in the sequences and series chapter where you wanted to find the sum to infinity. The sequence had to converge. It's the same with a binomial expansion. It will only ever make any sense, this infinite expansion, if each term gets smaller. And that's only going to happen if this number here for x is less than 1. Now, if x is less than 1, then what happens is you square a number less than 1, you cube a number less than 1, you do to the power r a number less than 1. It's going to get smaller and smaller and smaller. Each term is going to get smaller. Even if it's only slightly, it will get smaller. So these infinite expansions, where we've got a negative or fractional power infinite expansions, and they are only valid for the modulus of x less than 1. Okay, this ensures that the expansion converges, and it has a sum that it converges to. Otherwise, it doesn't make any sense. Yeah, so that's really important. Here we just write it in the form that we are used to. So let's write 1 over 1 plus x. We'll write that as 1 plus x to the power negative 1. Okay, so we're going to do the expansion of that. So the expansion is 1 plus nx. Now here n is negative 1, and the x that's in the brackets, well, that's just going to be x in our expansion. So 1 plus nx, negative 1 x, plus, and then we've got the bit where we've got n times by n minus 1, which is going to be negative 2 over 2 factorial x squared. Now how many terms do we want? 4, so we're going to do one more. The next one is going to be negative 1, so n minus 1, n minus 2 over 3 factorial x cubed. Okay, so that needs simplifying. So you can see how this expansion will carry on forever, yeah, because you're just going to end up like carrying on doing the same type of calculation. So 1 is the first one, the second one will be negative x, the third one, this is going to be 2 divided by 2, which is 1, so that just becomes x squared. That's the third term. Now the fourth term, so we're going to have 2 there times by 3, which is going to be negative 6 over 6. That's going to be negative, so it'll just become negative x cubed. Okay, and I'm guessing maybe the next term will be plus x to the power 4. Normally you would need to state when this expansion is valid, and so this would be valid for x less than 1, so valid for modulus of x less than 1. And in general, it's what you have written here, less than 1. Here it's plus x. Now if that was plus 3x, then it'll be the modulus of 3x less than 1, and then we'd simplify that down to x is less than maybe a third, modulus of x is less than a third, something like that. Or if it was negative 2x, we need to do the same thing. So look for what comes in that second part of the bracket, and that will help you decide what you need to write down for this range of validity of the expansion. Before I do this, I'm just going to write at the top what the binomial expansion is. So 1 plus x to the power n is 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial x cubed, and so on. So I'm just going to write that so we've got it for reference. So in the questions, the first thing you need to do is to see, right, do you need to write it in a different form? Part A I don't, part B I'll need to, but it's fine as it is. The second thing is, the two things we need in the expansion are, what are we going to put where n is? And in this case we're going to put a third. And what am I going to put where x is? Now I need to put in this one negative x, because negative x is what appears in the bracket here. Whatever appears in that second bit of the bracket is what goes as x in your expansion. So if we write this out, we will have 1 plus nx, so that's a third, times by negative x, so x gets replaced with negative x, plus, and then n times by n minus 1, which would be negative 2/3 over 2 factorial x squared, negative x all squared, plus n times by n minus 1, which is negative 2/3, times by n minus 2, which is going to be negative 5 over 3 over 3 factorial x cubed, negative x all cubed. So it's really important that you cube or you square everything that's in that second part of the bracket. Don't just square x or cube x and put a negative sign in front afterwards. That will be wrong. So now let's tidy this up. So you've got 1 minus a third x. Now for the next one, I'm going to have at the top negative, and I think the whole thing is going to be negative because I've got one negative, and this is going to end up being positive anyway. So I've got 2 over 9 divided by 2. So 2 over 9, that divided by 2 will give me 1/9. So I'll get negative 1/9 x squared. Now for the next term, let's have a look. Those two negatives will make it positive. but when you cube a negative it becomes negative, so we'll put a negative sign in, so we'll get that in first, then we'll work out the number. Now at the top of the fraction I will have 1 times 2 times 5, 10 over 27, and 10 over 27 is going to get divided by 3 factorial, which is 6, so I end up with 5 over 81. So negative 5 over 81 x cubed. Now I need to say when this is valid, what it's valid for. Now it's always valid for that thing that we replaced x with less than 1. Now we replaced that x with negative x, didn't we? Now we always need to write our validity expressions in the form, and I'll write it up here, x is less than something. Yeah, don't leave negative x here, or 2x or 4x or whatever, don't leave that here, or half x. Change it so it's x. Now because modulus makes everything positive, well actually we can just change negative x to x because it's going to give us the same answer. So this basically is what it's valid for. So here's what the expansion is, and this is what it's valid for. Part B. So first thing, write it in a form that we can expand. So 1 plus 4x to the power negative 2. In this one, I'm going to replace n with negative 2 in expansion, and where I see x in the expansion, I'm going to put 4x there. So let's now do that. So we will have 1 plus nx, so 1 plus negative 2 x, which is 4x, so there's my nx, plus n times n minus 1, so that's going to be negative 3 over 2 factorial, and then x squared, so that's 4x squared, not just 4 and then just the x squared, but the whole thing squared, plus n times n minus 1 times n minus 2 over 3 factorial, and then 4x all cubed, plus dot dot dot. So simplifying time, 1 minus 8x. Now the next term is going to be positive, yeah, because there's only 2 negatives there. So I've got 6 over 2 factorial, so that's going to be 3. Now that 3 needs to get multiplied. Let's write it down. I'm going to write 3 times. Now 4x all squared is 16x squared. I'll simplify, I'll do one more step in a minute. The next term here is going to be negative because I've got 1, 2, 3 negative signs. So negative. So 2 times 3 times 4 is 24. 24 divided by 3 factorial, which is 6, is 4. So I've got negative 4. And that's going to get times by 4x all cubed, which is 64x cubed. So final step here, 1 minus 8x, 3 times 16 is 48. 4 times 64 I think is 256 x cubed. So it's going minus plus minus and plus dot dot dot. When's this valid for? Well, we start with 4x in brackets like that, less than 1, the modulus of 4x less than 1, and then what we do is we divide it through by 4, and if we divide it through by 4 you end up with the modulus of x is less than a quarter. So this is when it's valid for, when x is less than a quarter. So let's just highlight that. So final answer there with the range of validity there. Here we've got an expansion. Expansion of 1 minus 2x up to and including the x cubed term. Right, so write it in a form we can expand. So 1 minus 2x to the power half. So in my expansion, x is going to be, or n is going to be a half. X I'm going to be replacing with negative 2x. So we need to take care with this. So that's going to give us 1 plus nx. So half, there's n, x is negative 2x, 1 plus nx plus n times n minus 1, which is negative a half, over 2 factorial, x squared. Now x is negative 2x, so all squared, plus, now we're going up to the x cubed term, which is fine, half times, or n times n minus 1 times n minus 2 over 3 factorial x cubed negative 2x all cubed. Simplifying time. So 1, the next term is going to be negative, half times 2 cancels out, so just f of x. The next term, now this is going to be positive here, and then there's one negative, so the next term is going to be negative as well. Then I've got a half times half is a quarter divided by 2, which is an eighth. So let's write that down. So we got an eighth times by negative 2x all squared, which is going to be 4x squared. Then the next term, now what's that going to be? These two negatives will be positive. When you cube a negative, so that's going to be negative. So the next term is negative as well. It looks like they're all going to be negative. So at the top, we have half times 3 over 2, which is going to be 3 over 8. So we have 3 over 8 at the top, and we need to divide that by 3 factorial, which is 6. So that becomes 1 over 16. So 1 over 16 times by this negative 2x all cubed. Now we've accounted for the negative here already. So we just need to write down 8x cubed. 8x cubed. And we'll simplify that even further. 1 minus x, an eighth of 4 is a half, so we've then got minus a half x squared, and then 1/16 of 8, well that's going to be a half again, so minus a half x cubed is going to be our expansion. Now we need to say what's it valid for. It's always good practice. So this is valid for negative 2x less than 1, which is the same as 2x less than 1, and if we divide through by 2, that's when x is less than, or modulus as x is less than a half. So we shouldn't be substituting any value into this which is not between a half and negative a half. Okay, and let's do our expansion there. Now the good thing about these expansions is you can use them to work out roots and approximate roots really easily by substituting appropriate value into your expansion. Now it says we need to substitute into our expansion x equals 0.01. Now the first thing to notice is that this value of x works because we said our value of x can only be between half and negative a half. That's definitely between that, so that's fine to substitute in. Now if we, and it says that we need to use that to estimate the square root of 2. So this is how we're going to do it. So the first thing we're going to do is we are going to look at what happens when I substitute 0.01 into the basically left hand side of the expansion. So I get the square root of basically 1 minus 2 times 0.01, which is 0.98, which is I think 49 over 50, so 0.98. So when I substitute 0.01 into this, I'm going to get an estimate for the square root of 0.98, which is no good. I want an estimate for the square root of 2. So we're going to see, what do I need to do to the number I get out of this to turn it into the square root of 2? Well, this is where we're going to maybe use our rules for surds. So let's write that 98 as, so 0.98 as 98 over 100 and see what we can do. Well, let's have a look. Well, 98 is 2 times 49. Now we can use the rules of surds to actually simplify that. So if we square root everything, what do we get? We get square root of 2, and we get the 7 there. and it's the square root of everything, by the way, over 10. Now if I want to change that into the square root of 2, I need to times it by 10 over 7. So I'll just run through that again quickly because this bit can be a bit tricky. So the question said substituting this value into the expansion, which we're going to do in a minute, to estimate the square root of 2. If I actually substitute that value into that expansion, it will give me actually the square root of 0.98. And I want to use the square root of 0.98 to find the square root of 2 because I just put in the 0.01 here. Now if I write that as 98 over 100, this next bit may not be obvious straight away. Yeah, it just sort of comes with practice. If I write this as 98 over 100, now 98 is 2 times 49. Here I've got square numbers. So all of that, if I square root it, becomes 7 root 210. That's the number I want. So if I times this by 10 over 7, I get square root 2. In other words, if I times the number that I get out of this by putting this number in, I times it by 10 over 7, I get my estimate for the square root of 2. So let's start by substituting the 0.01 in first. So that will be 1 minus 0.01 minus half times 0.01 squared minus half times 0.01 cubed. Okay, we're stopping there. And then what I'm going to do, as I said, all of this bit here, that is the square root of 0.98, yeah, because of the number we put in. So now let's do it in a different color. If I times this by 10 over 7, it becomes my estimate for the square root of 2. So let's do that on our calculator. 1 minus 0.01 minus a half times 0.01 squared minus a half times 0.01 cubed. Now I'm going to see if this is a number that I can write down. Well, this becomes, I'll write it down here, it's not particularly nice, 0.9899495. So that's basically like the square root of 0.98. Estimate for the square root of 0.98. Now times that by 10 over 7, it turns it into the square root of 2. Ah, that's pretty nice. I get I know it's 1.414. Look at that, 1.414 213. It doesn't say how many decimal places, but that's pretty good. I can see to at least 3 decimal places, maybe even 4. That's correct as the square root of 2. Now part C, how could my accuracy be improved? By actually writing more terms out of the expansion, by writing out more terms of the expansion. But pretty much with 3 terms, that's not bad. I think that's pretty good. So we have another sort of bit here to our expansion which we've not had before. We've got like this 2 plus x at the top. So first of all, we're going to write it like this. So 2 plus x times by that bit at the bottom brought to the top, 1 plus 5x, and that will be to the power negative a half when we bring it up. We are going to do the binomial expansion on this bit, and then once we've done it on that bit, we'll times it by 2 plus x. Now when we do the expansion on that bit, it means that we are going to, where we see n, we're going to put negative a half, and where we see x in the expansion, we're going to put 5x there. Now because the question is only asking up to the x squared term, or not up to the x squared term, just the x squared term, we don't need to expand up to the x cubed term. So we're just going to do up to the x squared term and then multiply it by 2 plus x, and we're just going to pick out the bit that we need. So it's going to be 1 plus nx, so 1 plus nx x, which is 5x, and we only need one more term, which is n, which is -1/2, times by n minus 1, which is -3/2, over 2 factorial 5x all squared, plus ... So we don't need to go any further than that. Let's simplify that. So that'll be 1 minus 5 over 2x. Then this bit here, all of this term is going to be positive because the negatives are going to cancel out, so plus. Then we've got 1/2 times 3 over 2, which is 3 over 4, and then we've got 3 over 4 divided by, or 3/4 divided by 2 factorial, which is 2, so 3/4 divided by 2 is 3 over 8. And then let's write down the 3 over 8. I don't want to do too much without really explaining. So 3 over 8, that's going to get times by 5x all squared, which is 25x squared. So actually what that becomes is 1 minus the 5 over 2x, and then 3 over 8 times by 25 gives you 75 over 8, so plus 75 over 8x squared. So this is the only bit that we're interested in, because now don't forget we need to multiply that by 2 plus x. So we've got 2 plus x in that bracket, and we've got 1 minus 5 over 2x plus 75 over 8x squared. So we're only interested in getting the x squared term. So really all we need to do is to multiply 2 by this, the 75 over 8x squared. That will give us an x squared term. The only other thing that's going to give us an x squared term is if we multiply x by this minus 5x over 2. So we don't need to multiply all of the terms out. We only need to multiply those ones that give us the x squared term. It will save time. So we've got the 2 times 75 over 8, which is going to be 150 over 8. So let's write down what we've got. 2 times 75 over 8 and x squared plus, now it's going to be minus 5 over 2x squared. So what's the x squared term? Well, it's this 75 over 8 times 2, which is 150 over 8. Take away 5 over 2, so subtract 5 over 2, 2.5, and we get 65 over 4x squared. So 65 over 4, 65 over 4x squared. So there's our answer for part A. That's the only term that we're interested in. Part B, state the range of values for which the expansion is valid. So what we need to do is to look at what we've got in the bracket that we expanded, and that was 5x. Yeah, so always look back at what you replace x with. That goes in the modulus sign, less than 1. Now if we divide both sides by 5, we'll get x, the modulus of x is less than 1/5. So x needs to be between plus 1/5 and minus 1/5 for this expansion to be valid. In other words, for this expansion to converge, not diverge. In this question it says, in the expansion of 1 plus kx all to the power -4, the coefficient of the x squared term is 20. Part A, find the value of k. In other words, work out what this is. We will tackle this in the same way that we've tackled all the expansion questions, and that is we need to decide in the expansion what are we going to be writing for n, in this case it's -4, and what are we going to be writing where we see x in the expansion, we're going to be writing kx. So we're interested in what the coefficient of the x squared, or sorry, not the x squared, the x term is. It tells us it's 20, so whatever we get, we equate it to 20. Right, so 1 plus nx, so n is -4, x is kx, Now we don't need to go any further. What's the coefficient of the x term? Well, it's negative 4k. So coefficient of x term is negative 4k. We're told that that's 20, so we just equate that to 20. Negative 4k equals 20. Nice easy one. K equals negative 5. Okay, so that's part A. And then it says find the corresponding coefficient of the x squared term. Oh, so we do need to carry on. So I will just carry on the expansion that I did before. So I've got 1 plus, now that I know what k is negative 5. So actually in the expansion, I'm going to, it's still got, n is going to be negative 4, but where x is, I'm going to put negative 5k or minus 5k, so minus 5k. Oh, sorry, just minus 5. We've worked out k, haven't we? So where x is, I'll put minus 5x, negative 5x. So let me write that expansion out with that information. So it's 1 plus nx, so that's negative 4x plus, now we could have gone straight to this if we wanted to write down what the x squared term is. So that will be n times by n minus 1 over 2 factorial negative 5x all squared. So the bit we're interested in is what this, and I suppose that makes. Right, so let's work out what that is. So negative 4 times negative 5. Well, actually, let's work out whether this term is going to be positive or negative. So positive there, that's going to be squared. So it's a positive term. We're going to get basically 20 there at the top divided by 2, which is 10. So I will get 10 times by whatever negative 5x all squared is, which is going to be 25x squared. So that's 250x squared. So the corresponding coefficient that they want is 250 for that one. Right, you should now be able to do exercise 4A on pages 96 to 97 of the textbook. And what I'll do, I'll just write down the expansion here just for reference. So 1 plus nx. So this is when you're doing the expansion of 1 plus x to the n. 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n minus 1, n minus 2 over 3 factorial x cubed, and so on. And remember that this expansion is only valid, expansion is valid for the modulus of x less than 1. So if you were expanding, I don't know, 1 minus 3x, then you would put negative 3x or minus 3x in there, which you can change straight away to 3x, which you then change to x, the modulo of x is less than a third, by dividing both sides by 3.